Hey Millie Molly. Okay, so I just quickly set up a file over here. Excuse my kids in the background there. So our normal understanding of milling is what you see here. This shouldn't come as any surprise to you. This is just a raster path over an existing piece of geometry that's had all the detail already cut from it, being booleaned. Alright. When you work with engraving, you need to stop thinking in 3D and you need to start thinking like ArtCam users in 2.5D, because it works differently. Okay, you need to specify your depths. You can use your model to determine it, but it works easier if you just know what you're doing, especially because of the way that we have to zero out Z later on. I'll explain that all as we get there. So your normal way, you can use the normal way if you really wanted to cut to metal, but it would just take a hell of a long way. It would take a hell of a long time. And you can also use tapered cutters, but I'm going to show you another way, if I may. You can use the 2.5D in your create menu. In the 2.5D, you've got a thing called pocketing. Alright, which is one of the ways you can go. What pocketing will do, it will use your outside curve. It'll find, you give it the tool will work on the inside and will cut away in a sort of raster fashion. It will pocket it out, like you're emptying a pocket out. It'll take it out and you will specify how deep you want it to pocket it. And let's just discuss the tooling for that. If you are happy to just use tapered cutters to do that, I've never tried to use a tapered cutter to cut metal. Alright, to be honest with you, I don't know how well it would work. Maybe that's a good question to post to 3D CAD. I've normally used the small versions of a flat end mill or a ball end mill. Alright, the difference between the two being, let's turn that path off. The difference between the two being what you expect from your finish. Alright, so that's obviously the kind of finish a tapered ball end will give you. Give you a nice radius to inside. Let's just switch it over to rendered. So it'll give you a nice sort of soft inside like that, versus a flat end mill, which is going to give you a very hard inside. Okay, so pick your own poison in terms of what it is that you want to work with for your finish. I don't know that there's any strength advantage of the one over the other. So that's your tools, and then obviously there's some design things that you need to be aware of. You can't make geometry smaller than the cutters you can buy. So check with Bits and Bits what the smallest end mills they use, and tapered ball end mills, and then also just the smaller an end mill gets, the harder it is to use it to cut metal, because obviously smaller breaks easier. So half mill end mill is a fairly robust end mill. If you push it hard you can break it though, but the rewards outweigh the trouble of setting up. Now every mill has its own idiosyncrasies, and you'd have to maybe buy a couple of cutters spare and just practice a few times. Okay, and I'll speak with you about that in the parameters when we come to it. So we discussed in the 2.5. In the 2.5 you can do a pocketing routine, which is basically going to go jiggy 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 jiggy, and it's going to cut between the two lines until a certain depth, and it's going to go down in levels. I don't like pocketing routines. They're a little bit hard to control, and sometimes they don't give you a nice edge finish. Right? I prefer an actual engraving routine. I'm going to show you, number one, I'm going to show you the engraving routine, not using a spring-loaded engraver, using an actual end mill to go down and cut it. All right. So, like I said before, you have to stop thinking in 3D. You've got to start thinking in 2.5D, because you have flat curves that you're using. Right. The first thing you need to know for engraving is you have to have a single line font. So I just used Comic Sans over here, and I kind of drew a line in there, and because I know my end mill's round, I've stopped the end of my line halfway from there. Alright, and I've kind of drawn these curves in there. If you have a look on CNC Zone, there's quite a few engravers fonts, single line fonts, that you might find quite handy. Alright, otherwise you can just sketch out what you need. Alright, so let's get to the nitty gritty of it. So the first thing we're going to need, I'm just going to turn those guys off because they interfere with when I create stock. So let's create some stock. So this is just so you can see what you're doing. Part box stock. Hang on, I've got to extrude this. Extrude it, I don't know, whatever, down to there. Okay, now Rhino 5's extrusions are not visible to RhinoCam, okay, just be aware of this. That surface RhinoCam can't see. So I'm just going to fillet edge to force it to turn it into a real piece of geometry. Okay, notice that there's now a square through there. Alright, so I'm only putting this here as a source for creating stock. So I'm going to create the stock, part box stock, and go OK. Alright, so we've got this bit of stock over there. I can now hide this. It's of no use to me. So as long as I've got that piece of stock there, I can test that what I'm telling you is actually true. So, okay, so engraving, let's think about logically what's going to happen. You've got this thing stuck down to the table of your mill with some double-sided tape, or I don't know, you've got some kind of holder, or however you want to hold it, it's really going to be up to you. Yeah, some people have fixturing systems. If you know how to hold your part, once you've got that part done, I'm going to carry on from here. You may want to grab, there's all kinds of little holding things that you can stick onto the top of your mill. I'll shoot a few in the link afterwards. Alright, so let's get stuck into the actual engraving routine. So I'm going to create a new mop set, and I'm going to call it engraving. I'll turn on the light here because it's pitch black in my cave. Alright, we call it engraving. Right, now you need to think logically again what's going to happen if you try to stick. You want it to go down to about 0.4. If you try to stick one piece of metal into another piece of metal 0.4 deep at one go, one of the two pieces of metal is going to break. Alright, so you've got a thing called DOC, depth of cut, is how much you're going to cut away on each pass. So part of this, like if your tool is really strong, you can maybe go down 0.1 per pass. You'd have to go down in 4 or 5 passes. My recommendation is, while you're playing with this, rather go too many passes, that takes a bit longer, than break the tool. So go, and then the next time you try it, use a few less passes, a few less, until you break a tool, and then you know what the tolerances on that tool are. You can't push that tool any more than so much at a time. Depth of cut will also depend on how fast you're pushing the tool. Alright, so let's actually, maybe the easiest thing to do is just to get into it. Okay, so let's go to engraving. Alright, so the selected regions, what is it we want to engrave? You'll notice that for the circle I've created a little round curve there. Okay, I'm going to grab all of that. Oopsie. I'm going to go select curves as region. I grab that, I'm going to press enter. Alright, so it's got all the curves. What tool? I'm going to use an 0.5 N mill from Bits and Bits. Feeds and speeds, I'd probably crank these all the way down to maybe 100 mil a minute. Alright, until you know what you can handle. Okay, and initially you may want to just set up some sort of lubricant. I think a lot of guys are using WD-40 and that sort of stuff. Alright, so feeds and speeds are done. Clearances you can just leave. Now cut parameters is how fine this is going to cut. I'm going to put it on, I don't know, that seems a bit like an overkill. You can leave this menu there. What it's asking is, where's your cut geometry? At the top. We're at Z0. I'm going to explain to you just now why that's at Z0, and just leave that at top. Now this next little dialogue down here, what is the total cut depth? How deep do you want to cut in? So in your case, I think you said it was about 0.4, huh? 0.4, alright. And the rough cutting, alright, how much of it do you want at that sort of tolerance, and how much do you just chunk out some metal? So the rough depth I'm going to make 0.3, and the really fine finishing depth is going to 0.3, and the finishing depth 0.1. Now it's asking, this is your depth of cut. How much per cut do you want me to go down? I'm going to chunk it down to like maybe 30 micron at a time. I don't know. 60 micron. Ooh, you may be able to handle it. I'm going to say leave it on 30, and for your finished depth you want it to cut really clean. So put it on something really fine, maybe. You with me? That might be too fine. Okay, it might take forever to do. Alright, so then your entry exit, you don't need to worry about anything, and your sorting, you don't need to worry about anything. So let's generate that. Okay. I need to show the path. So you can see what it's done. It's creating this path That's going in, it's cutting once, and then it's coming back, and then it's going, then it's cutting, then it's cutting, then it's cutting. It's going down in very small increments into the metal until it reaches a total depth. Right. So anyway, the proof of the pudding is in the eating. So let's get into the simulate menu. How come my pot? There it is. And let's simulate that engraving path. Okay, I might turn my speed down. Go OK, and go in the simulate and press play. Alright, so okay, even the slowest simulation is going pretty fast. Alright, now you can see what's happening is we haven't come exactly to where the font was originally, but because we used a centerline font, I might change the model from polygon, which is quite rough, into a voxel model. Go yes and just go OK and re-simulate that. Simulate. Ugh. I didn't look too much better either. Why is that doing that so rough? Let's have a quick look. Okay, simulation accuracy, polygonal model. Okay, simulation, how fine. Okay. Alright, so anyway, let's just run that. Simulate. And let that run. Alright, and let's turn off the toolpath. Alright, so you can come in and examine this virtual metal that you've got. Alright, we're talking about very, very, very tiny parts over here, so you can see the faceting in the mesh, but obviously your metal is not going to look like that because your cutter is round and it's going to spin around circle over here. Okay, so just bear with me a little bit on that. Like that wouldn't be 8-sided, it would actually be round. So this is how it would cut it straight down. Now of course, if your 0.5 was a ball end, you'd have a rounded corner inside there. Okay. For setting up your tools while we're in there, because I know that's probably going to be the next thing. Let's double click this. Let's go to a ball mill, diameter 0.5. I don't know how long that is, I'm just going to leave it like that. I'm going to go 0.5 ball nose and go save as a new tool. Okay. Alright then, let's in the engraving pick the ball nose this time. I'm going to pick the ball nose and generate with the ball nose. Right, now let's go simulate it again. And why can't I see my stock? What's happening over here, people? Okay, let's just show that. Oops. Let's go to simulate engraving. Oh, there we go. I'm not seeing a ball nose. Did I pick the right thing? Ball nose. Diameter. That's right. Tool length is right. Ball nose is right. Okay. Save. Simulate. Okay, I might create new stock because this thing seemed to be having a little bit of a, it's having a bit of a fart. Alright, so let's delete the stock. Let's show my little odds and sods and let's create new stock. New part box stock. Okay. Right, and let's hide that part. And let's simulate that. What is going on with the stock? I'm not entirely sure what's going on with that, Molly. But anyway, so what's going to happen is, let's hide that. What's going on with the stock? Okay, so my Rhino cam's having a bit of a fart at the moment, but with the ball nose, what will happen is you'll get a little radius edge on the bottom there. Okay, so I'm going to get into this a little bit more on how you're going to then set this up to I'm going to go over there and I'm going to get back in the setup. Okay, there we go. Alright, so I'm not sure what the hell's going on over there, but now you can see that radiused, you can see the radiused edge we were talking about. So it's because the tip of the cutter is radiused, you've got a radiused finish inside there, so you may want to consider getting a ball end because it makes it really nice. And in metal, your final pass will be really shiny, they look really good. Okay, so a little bit about how to set it up now. So I'm going to close out the Rhino cam half of this for now, Actually I need to bring it back because I want to get rid of that stock. Delete stock. I want to get back in the setup menu. Alright, so how you would set this up, alright, is if you were going to cut, your paths are all written at Z0, okay, on the ground plane. I'm going to dump that too so it doesn't confuse us, and I'm going to dump that path, regular, delete. No delete button. Okay, so this is all your engraving path set up over there. We've gone down in 1, 2, 3, 4, gone down in lots of little passes, alright? And for example, we're going to use the ball end, alright? So on your machine, let's extrude that. You've got this disc. Now what you're going to do with your cutter, alright, is you're going to have to manually, because this time you put the coin down here, next time you put it there, next time you put it there, next time you put it there. What you're going to need to be aware of is that you can't have a fixed X and a Y as you are used to at the moment, right? So you're going to go in Mac, you're going to load your cutter, and you're not even going to bother, you're going to home and probe whatever it is you want to do, and then you're going to drive your cutter over manually, okay, until you find the middle of the coin. You're going to have to sort of use your judgment a little bit on that. So you're at the middle of the coin there and the middle of the coin there. And remember, I say that because you might have the coin out this way. You may want to take a divider and just make a little light mark on your coin or your metal or your plate, whatever it is, so that you can drive the cutter tip over to it. All right. And when you drive that cutter tip over, you're going to bring it down. You're going to use a loop, and you're going to see when it's just touching the table. Okay, I mean the coin. So it's only. What I do is the plastic wrapper on a cigarette box. If you can slide that under there, and then you touch it with the cutter, and you can still slide that little plastic wrapper up. That's close enough. Okay. And then once you've got this centered up nicely relative to the X and Y zero of the path itself, then you're going to go in your Mac and you're going to zero out X, you're going to zero out Y, and you're going to zero out Z. And then effectively you've set everything at your datum Z zeros. Okay, at that point you're going to pick your cutter up, maybe 20 or 30 mil, and you're going to go run path. Alright, and then it's going to come in and it's going to go in the first 1 or 2 passes, may just cut in the air. Alright, that will depend on how close you got this to touching. So if you don't go down the whole 0.4 and you only go down 0.35, you know, it's better than trying to slam in, Control Z, it's better than trying to slam in too much at one go and breaking the cutter. Alright, so that's just a little bit about that kind of engraving path. The other way that might work well for you uses a similar method, but you get a V cutter. Alright, and the difference will be you won't have straight walls down. You would have 60, 90 or 120 degree V's cutting in there, and the V cutter looks like, let's have a look at that. Let's create a new tool. Oh, come on. New tool. Alright, so where's V-mill? V-mill, that's you there. Drill, no, where the hell's a V-mill? Where are the V-mills? Taper mill, V-mill? No, that was the drill. Alright, now this is starting to freak me out. Where's the V-mills gone? Corner radius mill. V-mill, there we go. Alright, so V-mills you can also buy from most places, and there'll be a carbide mill, and there's a little cutting table over there. So you also need to go in with it slowly, but it's got a very strong face, because you can have a 90 degree corner, you can have even a 120 degree corner, which is relative to the same as what a nice engraving cutter is at 120 degrees. Okay, and what will happen is with V-mill you've got a different path again that you run. Okay, do I have any V-mill set up? No, let me set one up quickly. Where did I find that V-mill? So taper angle, I'm going to make that 45 for 90 degree cutter. We can make it 60 for 120 degree cutter. I don't know, 20, and flute length is, I don't know what, 35. Hold the diameter is 3.17. V-mill test. I might be wrong with this, it's been a long time since I played with these things. Say there's new tool. Invalid tool definition, taper tool length, taper angle, too much, 45, flute length 10, whatever, save as new tool. Alright, V-mill test one. So you have actually a different pathing method for V-mill. Now you may have to ask some of the guys on 3D CAD to help a little bit more with this, because I'm not too aware of how this system works, but you can grab the outside curves. Alright, so I'm going to unlock them. What I might do is grab all those guys and group them, and then I'm going to unlock and grab all these guys. After you lock your bum, and grab those guys. Alright, so they are already grouped. Hang on a second, and group them. And I think it's called V-carve or something like that. I'm not 100% sure, but have a look in your 2D menu, 2.5D, V-carving. Okay, so V-carving wants a V-mill. There, you see it's automatically highlighted by itself. I'm going to leave everything on there, and what do we got? Part man, okay, cut parameters. So total cut depth is, I don't know, 0.4. Rough depth 0.3. So same deal, alright, it's just that you're going to be working with a different cutter that's going to give you a different sort of finish, and I'll show you now how it works. And let's go generate. Alright, so let's unlock that, hide, and you'll see that what it's doing, it's creating like an engraved look using the V-mill. So I'm going to create some more stock work. So now let's go to the V-carving, let's go to the simulate menu and simulate that. Okay, let's hide that piece of stock. Not you, you. And you can see what that does. Okay, once again, it looks rougher in the simulation than it actually is in real life. As it goes in, and it creates quite a nice V inside there, right? So it cuts down exactly what it says it's going to do, V carving, right? So it goes in and creates this nice, deep engraved relief thing going on there. And this is quite handy for a lot of things, because see what it does over there? Got quite a fancy look going around the corner. Okay. So there's a variety of ways of doing this. The V-mill method is very strong. Those V-mills are almost indestructible. So I'd maybe recommend looking at this method versus the flat or the ball end mill. It all really depends on what you're trying to achieve in terms of the look of your part. Okay. You can export this as an STL and render it and have a look. I'm going to stop that for now. That's 25 minutes worth of stuff. I don't want to confuse your head, but from having watched this, you may decide it's for you or it's not for you. I hope at least it helps you get that determination. Anyway, lads, you have a good one. Cheers. Chris out.